internet is there. I will first give you a look, an overview, and then if there's time, you may wish to try one. So if you go to the website, we have the various services, and services are categorized depending on the kind of data treatment you can do. So you can actually do some assignments, you can do data analysis, and as we care of now, you can do structure calculations, and you see we have different programs. So these four were all in the WeNMR assessment. So in principle, if one wants to try some automated calculations, we do provide the resources to do that. And this Xplor-NIH instead is one of the traditional ones where you don't do the automated assignments. I have to say these programs like Cyana or Unio can be used both in automated mode or in manual mode, so to say. So if I click here, I get transported to the portal. I will show you the SSO in a minute. For now, since I'm a registered user, I just need to type in my username and password, which is what you will be able to do after you have completed this single sign-on procedure. I get in here. So here, this is a common space that's similarly organized for all the portals we have in Florence. So if you actually want to follow me, let's do the single sign-on now. Maybe it will allow you to follow me better. So to do the single sign-on, you must have registered with the VRC. That's mandatory. So you go here and log in slowly. Try again. Let's go via Google. No, it's gone. Whatever. Let's see if mine is more stable, though it looks worse. It's up again. As I said, you go, sorry, you hit the login button, you go to the user account. This you must already have registered and been approved here. So if you now log in here, you will get transported to this page. If you now hit My Services tab, you will see a list of services that are enabled via this single sign-on page, which is not all of the services. Some actually do not require a password, because if it's just 5 seconds calculations, we don't care of having users log in via password. So this is a demo user, so I did not subscribe any of these. If you actually want to do the subscription, oops, it's already subscribed, so it's just unsubscribe this. So if you don't want to do the subscription, this is the software suite that was discussed yesterday. You go to subscribe, it gives you this drop-down menu. First step, you see the license, you agree. You just go to second step, you submit, and it's done. Slowly again. So let's try. So this will have worse resolution, but so if now, for example, you want to subscribe to this Xplor-NIH one, as I was mentioning before, you still are requested to have the certificate, but this has been disabled for today. So if you just now click the link up here, it should transport you to the portal, the same one I was showing you before, but now you are already logged in. So it's the same portal, but we already skipped the login page. It's already in, and it's saying welcome and my name. Now this is just the demo thing. But that's valid for today, but at least you can see what I'm doing. And then you can download the data if you want to try.
Antonio, if they have the certificate and they try to log in using the certificate confirmation, do they get error message now?
I don't know, actually, I haven't tried.
Because I have problems with the single sign-on service.
We can, I can just go quickly through this, and then maybe we give it a try. I think that they probably disabled it, so it's not really doing the thing. So this is organized in this workspace. You have your own account thing, and then you have the three main menus. That is project, that's a personal workspace. Then you have jobs to look at your calculations, and then you have the setup page for new calculations. So if you go, for example, projects manage, you get this, let's say, simple directory scheme. Now, for example, you can create a new project. Just give it a name. 2KT0, always playing with the same couple of proteins. So now I created a project. It shows in my directory structure, and of course it's empty. So what I can do here is add a new calculation, and this will open the new calculation page. Or I could have gone here and say explore new calculations without going through the project page, and then it just creates a directory like this one at the bottom, which says new project and a random number. So if you want things to be nicely organized, you go via the project manager. If you're just happy with trying out things, you don't need to create new projects and so on. You just hit new calculation and you get a new directory with a strange number. So let's add this calculation here. Again, the couple of portals we'll be showing you today will always are all very similar in layout. So you have here you have just 3 tabs. You will see 4 tabs for the Amber refinement, and you start by uploading the protein sequence. Here we are just generating the structure from a random structure. As is typical for structure generation programs. So they take random structures and they fold them up according to the restraints you provide. So you don't need to provide anything at the beginning but the sequence and the restraints, because the random structure will be automatically generated from the sequence. So you have to select the sequence file, this one. And then you say chain A. This is a single chain protein, but of course if you want to have multiple chains, you will have multiple, you will upload multiple sequences and you will label them using multiple chain identifiers. Same chain identifier must be found in the restraints files. Okay? This is not mandatory actually. If you have only one protein with one chain, you can omit this chain identifier here, but you have to omit the chain identifier also from the restraints data. So, for example, if we take a look at one of these, this will be generated by the software you use to look at NMR spectra. So you see this is the format. This is an NOE between H-alpha proton of residue 2 and HN proton of residue 3. And in addition, you have this chain identifier A. This is actually optional in principle. If you only have one chain, you can tell your software to produce the restraint list without the identifier, but then you have to omit that from the calculation page. Vice versa, if it's here, it must be there. Otherwise, the program gets confused. And then this is the distance plus minus, this is the distance, target distance, plus the upper bound you obtain from the calculation, from the calibration. This is just the way it's formatted in this file. in other programs use different formatting. I will show you that later. So because this is just a standard polypeptide, we don't have to do nothing special. As you see, we have different options. For example, you have non-standard amino acids. You can add those methylated lysines, acetylated initial amino acid, things like that. You can instruct the program. You have a non-standard residue there. And we will have, hopefully, a look at the paramagnetic things. You can add cofactors. You can add disulfides and so on. Now what you want to do is calculate a given number of structures, say 50 or 40 or 100, and then you run the calculation. As you know, for each of these structures, the program will generate a random conformation, and then will wind it up according to the restraints. So you get 50 if you are keeping this default number. Independent structure calculations. At the end, you get 50 different conformations, and then typically in a, let's say, post-processing kind of thing, you will only select the best, either in terms of total energy or in terms of energy of restraint violations. This is up to the user. You will select the best structures, and you can use those for the subsequent refinement. So once you have filled this with the sequence and the identifier, you can just go to the restraints. And now here we are providing facility to upload the NOE data, the dihedral angles, for example, generated from Talos Plus, as I discussed before. You can upload residual dipolar couplings, which can be due to paramagnetic centers or not. And you can upload another kind of paramagnetic NMR information data, which I will mention in the afternoon. So for this very simple calculation, we just need to upload the restraints. This is a structure from the PDB, so I just downloaded the files from the PDB, and I'm recalculating the same structure. They come with these strange names. So if you actually open the files, you will see that the first one is distances, this one, block 44782, and the one with the final 3s instead is angles. So here you have the definition of the dihedral by the 4 backbone atoms, and here this is the central value plus minus 70 degrees in this case. This other dihedral is 154 plus minus 19 and so on. So you don't need to do anything else. You can just submit the job, because for a given protein you will be you may need to run different calculations. You can just give a name to the individual calculation. So it will check if this name has been taken already, and then it will submit. This is going to take some minutes, because what is the system is doing now, it's creating the input files, so it's uploading your data, is creating all the scripts that will actually run the calculation. Then it packages the scripts together and it sends them to the grid. And then it's waiting for the grid to send back an answer that they received the calculations correctly. This is taking a few minutes, because the communication with the grid is typically fairly slow, I have to say. That's also why if your job is only lasting for 30 seconds, 1 minute, it's not worthwhile sending it to the grid if it's one, because you will spend more time talking with the grid than waiting for the results. Of course, if you have to do 10,000 of 1 minute, then you can find ways where you bundle them together and you get a quicker reaction from the grid. So this will just keep looping until the grid has provided an answer that the calculation is either running or, is either submitted or refused. Okay, so it was actually quick. So now we are automatically transported to the jobs page where we are seeing all the jobs submitted. And you see that now, you remember I left untouched the default of 50 initial structures. These are actually divided into 5 calculations of 10 structures each. This is advantageous because by splitting the calculation, we run we run all of them in parallel. We cut time because the number of CPUs in the grid is large enough. You cannot split them too fine because otherwise, as I was mentioning, you end up spending more time waiting for the grid than actually doing the calculation. So you have, in a way, to balance between how finely you divide the calculation and how convenient it is with respect to the time you are waiting. Now these are all scheduled. They are going somewhere in the grid. The system is taking care. It will find the sites that's more readily available. So what you have to do if you want is to check if it's running or not by hitting this check all button. So now they are all running. So now in principle you can actually log out because you don't care to check this every 1 minute. You can come back. These calculations will typically take half an hour or so. So you just need to log in half an hour again and you can retrieve the results of the calculation. I wanted to check what's about the calculation we started before lunch. So if you go back to the Xplor-NIH portal via the SSO, as I just mentioned, and now you click Jobs, Show All, you go back to this page where you see the job status of all the calculations you ran. And actually, this is a permanent track of all of your calculations unless you remove them. So for example, I was testing the system yesterday. So you see this is the calculation that ended yesterday. So I started yesterday at that time and then it finished. It will stay there until I remove this job, which you can do here. So you can periodically clean the list. For example, you remove finish job, you select, sorry, maybe that was too quick. You go here, you select the status of the jobs you want to remove. So you want to remove all jobs that are finished already. You go here, you select E, and then you say remove, and which I just did, and as you see now the one that I ran yesterday as a test is no longer in the list. Okay, it's gone. These are still shown as running, but actually, as it says here, the job status does not automatically update, even if you log in and log out. This is because checking this job status means connecting to the grid, retrieving the information, so it's it can be slow, as you experienced before lunch. That's why we don't do that automatically, because otherwise every time you open the page, you just stare at the thing going in wheels for 3 minutes. So but now that's actually what we want to do. So we say check all, and we see what happens. So it's still running. We will have to wait another little bit. Okay, meanwhile, we can just move on and see what, how the Amber portal for refinement works. So when this structure will have finished, sorry, the calculation of this structure will have finished, we will be able to retrieve the corresponding PDB. And if we want to do that, and as I say, I think it's always very worthwhile to do it, we can send it to the Amber portal for refinement.